Assalamualaikum and hi, my name is Nur Amirati binti Muhammad Syekani, and today I'm going to present my geosynthetic design project, which is a case study on the design and application of geosynthetic in retaining walls. Here are the content that I'm going to elaborate, which I will start with the introduction and I will move on to the aim and purpose. Then I'm going to elaborate on the materials, case study, and lastly I will explain in the conclusion. Generally, geosynthetic was referred as a product that made from polymeric materials and has been used as a key component of a structure for engineering purpose. Geosynthetics has been used increasingly in geotechnical and environmental engineering in the last 4 decades, in which it helps designers and also contractors to solve several types of engineering problems. There are a significant numbers of geosynthetic types and applications that exist in geotechnical and environmental engineering. The common types of geosynthetic that has been used in soil reinforcement are geotextiles, geogrids, and geocell. There are also a wide variety of geosynthetic products that can be used in environmental projects such as geomembranes, geosynthetic clay liners, geonets, geocomposites, and also geopipes. Because of geosynthetic are manufactured materials, the technological developments in the polymer and plastic engineering industry has been continually incorporated into geosynthetic products, and because of that, it enhances the relevant engineering properties of these materials. The combination on improved materials and design method has enabled for the engineers to face challenge and to build structures under the conditions that were previously unthinkable. The aim and purpose for this study is to analyze the design and applications of the geosynthetics that has been used in retaining walls. Here are the common materials that has been used in soil reinforcement geosynthetics. First is the geotextiles. It is a continuous sheets of woven, non-woven, knitted or stitched bonded fibers or yarns. It is also flexible and permeable and are generally fabric-like. Geotextile is ideal material for infrastructure work such as road, harbour, landfills, and other civil projects. Next is geogrids. Geogrids is a uniformly distributed aperture array between the transverse and longitudinal elements. This opening on either side of the sheet are allowed direct contact between soil particles, and it is commonly used in reinforced retaining wall as well as subbase or subsoil below road or construction. And the last one, we have geocells. Geocells is the thick 3D network built from polymer sheet strips. It is the strips that are joined to form interconnected cells that fill with soil and sometimes concrete. Geocell improve the performance of standard construction material and erosion control treatment. There are numerous developments in walls and slope in mechanically stabilized earth MSE and also in vessel stabilization. The concept of MSE is essentially a problem of uni-axial force that is served by the insertion of tensile members whose the main strength is uniaxial, and that property is oriented towards the expected forces of the failure in the design. Another advance in textile geogrid application technology is the development of the construction technique that allow the construction of bridge abutment where the sill beam rests directly on the geosynthetic reinforced soil block where the GRS block does not require a stiffening facing. As for the case study, in Queensland, Australia, a segmental retaining wall project reinforced by geogrid has been designed for a large industrial project which required 230 meter long of geosynthetics. The structure is located close to Brisbane River, which is midway between the Brisbane and Ipswich in the suburb of Redbank. The structure was designed to support the high vehicle volume for the main access road into the industrial park. According to the previous geotechnical investigation of the area, the site was believed to be underpinned by alluvial soil, which in turn overlies the sedimentary rocks. The structure's most critical section, which is more than 7.2 meter high, and is based on the soft to firm clay layer. And in order to prevent the potential bearing failure due to the excessive vertical stress and insufficient carrying capacity of the soft clay layer, a 750 meter thick layer of crushed rock fill was adopted in order to replace the existing soft clay layer as the ground improvement option. In addition, a concrete footing of 300 milliliter was casted as a rough foundation beneath the blocks. And for this design, they adopt the uniaxial polyester geogrids Miragrid 8XT as the reinforcement. As for the conclusion, geosynthetics have a great potential to be used as a cost-effective approach to many problems in engineering, and for classifying the damage of masonry structure with prediction of ground improvement, and also the calculation of strengths induced within the structure was adopted for the case study in Queensland, Australia. The long-term performance of the wall face subject to displacement were analysed by strain-based finite elements approach coupled with serviceability evaluation method for masonry structure. And the geosynthetic reinforced soil retaining walls present better performance under dynamic loading than traditional retaining walls. And this has been demonstrated by a number of case stories by using a prototype structures that have withstood severe earthquake. The new construction reinforced soil retention walls that include new facing units, reducing the construction time and cost, as well as allowing for better aesthetic condition for the final structure. That's all from me. Thank you.